So then there are times when the counting rules, in terms of just using a factorial or whatever, isn't going to help you all that much, but then you can draw the boxes like I've been drawing them and then just use the fundamental counting principle in order to figure out what's going on. So we've got to consider these single digits 1, 2, 3, 4, 5. So it asks us how many different numbers greater than 1100 can be created with the number above if you can use each digit once only. Okay, now it says numbers greater than 1100, okay, and I've got 5 numbers, okay. Now, any number that has 5 digits is going to be greater than 1100 because 1100 only has 4 digits, right? So the ways in which these 1, 2, 3, 4, 5 can be arranged if we select 5 of them is going to be 5 factorial because we can use each digit only once, right? So those are all the 5-digit numbers that we can make, and all of the 5-digit numbers are going to be greater than 1100. But then there are also some 4-digit numbers that will be greater than 1100. So to look at the 4-digit numbers, in order for it to be greater than 1100, right, we need to think, okay, what are the possibilities for this first column, right? So for this first column, if we, for example, select 1, okay, as in the number 1, and we put this here, right? Then the next digit is automatically going to be a 2, a 3, a 4, or a 5 that go in here. And then 1200 and something, or 1300 and something, or 1400 and something, all of those are actually bigger than 1100. Which then means we definitely can use a 1 in the first column, but we can also use a 2, a 3, a 4, or a 5. So there's actually 5 factorial ways in which this can happen. And then for the next one, there are 4 left. 5 factorial. Sorry, 5 ways in which we can choose the first number. 4 ways in which we can then choose the second, because we've already chosen one. Then 3, and then 2. So there are 5 factorial of these 5 digit numbers that are greater than 1100, and then there are another 5 times 4 times 3 times 2 of these ones that are greater than the 1100, and then the total number of digits, numbers greater than the 100 is going to be 5 factorial plus 5 times 4 times 3 times 2, which is then 240. Yeah, it's a bit less than I expected, eh? But I guess you can't repeat numbers, and that's probably why. Okay, cool. So then it is now, for the final time, your turn to please pause and try this example. Okay, so we've got the following 8 cards, and they've been taken from 4 different suits. So the suits is like the clubs, spades, aces, hearts, etc. Right, and then it's asked, in how many different ways can these cards be randomly arranged? Well, in a deck of cards, there are 54, but actually we're told we only have 8 cards specifically. Okay, so they can then be arranged in 8 factorial ways, because it's the same sort of thing where we have to choose 8 positions, and each of the positions, once we choose something there, it can't be in the next position. You've only got 1 ace of spades, for example, in the deck. And then it says, determine the probability that the cards are arranged so that the first card will be a king and the cards of the same suit are together. Okay, right, so this is a little bit more tricky, so let's see how this can happen. Okay, so let's say that we go and arrange this in our random way. Then we've got 8 places where this can be arranged. Okay, so it's going to look something like that. Okay, so we can either start with, well, we have to start with a king. So there are 4 of those. Okay, So we could either start with the king of clubs, or the king of spades, or the king of hearts, or the king of diamonds. Okay. But then if you start with the king of clubs, then we have to have the cards of the same suit together. So what's going to be next to it has to be the ace of clubs. If you start with the king of spades, it has to be the ace of spades. If you start with the king of hearts, next to it has to be the ace of hearts. And if you start with the king of diamonds, well, next to it has to be the ace of diamonds. So here we've got 4 different kind of scenarios. And then the rest of it is pretty easy to determine, because here we will have 3 groups next to each of them. So for each of these groups, you have to have the 2 together from the same suit, and that can then be arranged in 2 factorial ways. Okay, and then in terms of the suits, how those 3 groups are arranged, that can then happen in 3 factorial ways, right? So then these 1, 2, 3, 4 events, right, can happen in all of these different ways. The 2 factorial, 2 factorial, 2 factorial times 3 factorial. And so the ways to determine that is to say the 4 different events that I've isolated here can happen in the 2 factorial times the 2 factorial times the 2 factorial times the 3 factorial ways. And that pretty complicated example there is going to be the way in which we answer that question there. So, well done if you stuck through this with me the entire time, and especially if you did take the time to try those examples. I wish you all the best. Good luck.